Hello students, welcome to AIMSTOday online classes. This is a chemistry session. Here we are discussing about the chapter Introduction to Atom. In the earlier sessions, we have studied about what is an atom, what does it consist of, and we also studied about the discovery of fundamental particles like electrons, protons, and neutrons, and even about their properties also. And we have seen and atomic models which are explaining the presence of these fundamental particles inside the atom. Now in this session we are going to see a practice sheet, that is level 2 practice sheet on this chapter, which includes multi-character answer type questions, comprehension passage type questions, matrix matching, analytical approach questions, statement type questions. These all we are going to see from this practice sheet. Okay, let us start the practice sheet. Good. So first let us go through the multi-correct answer type questions. Okay. See the first among those. In Sanskrit language, Paramanu means. So we have studied about the Maharshi Kannad's proposal about the atom. He proposed that every matter, that is he said as every padartha, is made up of tiny particles called anus. These anus are composite of paramanus. So there padartha represents matter and anu represents molecules. So he concluded there every matter is made up of tiny particles called molecules, and these molecules are composed of still smaller particles which are called as paramanus. Paramanus are nothing but atoms. So these are the ultimate particles or final particles of every matter. That was a proposal given by Maharshi Kannad. So here Paramanu represents the final particles or ultimate particles of every matter, which we are calling as now atoms. So here we will get Paramanu, which representing final particle or ultimate particle, which is also called as atom. These three will be correct answers. Okay. Next one. Which one of the following is incorrect statements about proton? So proton is one of the fundamental particles which has 1 unit positive charge and even 1 unit mass also. Relatively, it is considered as 1 unit charge and 1 unit mass. Now let us see the statements given based upon this. Proton is positively charged particle. Is it correct? Yes. Proton is a positively charged particle with charge which is quantitatively equal to 1.602 into 10 to the power of minus 19 coulombs. This is a charge of each proton, positive charge. It is relatively considered as 1 unit positive charge. Okay, that is correct. And the mass of proton mass is 1.007 AMU. This is also correct, and it is also taken as relatively 1 AMU. The mass of proton is considered as 1 AMU relatively, but to say accurately it is equal to 1.007 AMU. That is correct. Next, proton was discovered by J.A. Thomson. Is it correct? No. Proton was discovered by Goldstein. J. Thomson discovered at the first electrons. Electrons were discovered by J. Thomson. After that, they discovered protons. These protons were discovered by Goldstein, not J. Thomson. So it is incorrect statement. Next, proton is heavier than electron. Is it correct? Yes. Proton is much more heavier than electron. If you compare the mass of electron and proton, the mass of one proton will be equal to the mass of 1837 electrons mass. Means around 2000 electrons if we take on one side, it will be balanced by the mass of one proton on the other side. So comparatively here, the mass of proton is much heavier than electron's mass. So this is also correct statement. What will be correct answer? A, B, D. Okay. Next one. Which of the following statements are correct according to Dalton's atomic theory? So what we have studied about Dalton's atomic theory? So atom is the smallest particle which cannot be divided further. It is participating in the whole chemical reactions and it combines in whole numbers to form molecules. Now let us see here the statements given. Let us see one by one whether they are correct according to Dalton's theory or not. Matter consists of small indivisible particles called atoms. Yes, it is correct. It is one of the points from the Dalton's atomic theory. Matter consists of small indivisible particles called atoms. He called these atoms as the ultimate particles of every matter, and he considered these cannot be divisible. They are the indivisible particles. With that meaning only, the name atom was proposed for those particles. Okay, this is correct according to Dalton's atomic theory. Second statement, atoms can neither be created nor be destroyed. Is it correct? Yes, according to Dalton's theory, this point is also correct. Dalton considered that atoms cannot be created and cannot be destroyed because they are ultimate particles of every matter. In that way he considered. So this is correct according to Dalton. Of course, nowadays it is proved as wrong because atoms are being created and even they are being destroyed also in the nuclear reactions. So those were discovered later. But according to Dalton, this is also correct. Next one, atoms combine in small whole numbers to form molecules. Yes, it is true. Atoms are participating in the small whole numbers to form molecules. This point is also true according to John Dalton's theory. But of course, it is also kept failed after this discovery of polymers. What is happening in the polymers? Atoms are combining in the large whole numbers, not one or two. Very big number of atoms they are combining together to form long chain molecules. So this is contradictory to Dalton's atomic theory proposal. That is, atoms are combining only in the small whole numbers he considered. So here the statement is given which is correct according to Dalton's theory. Next one. Atom is the smallest unit of matter that is taking part in chemical reactions. So this is also from the Dalton's proposal only. It is also correct. And even it is the only point which is being correct even now also from the Dalton's proposals. Remaining all concepts or proposals were failed by the discovery of these fundamental particles and others. But the only one point is being correct till now from the Dalton's atomic theory is this point. That is, atoms are the smallest particles of every matter which are taking part in the chemical reactions. This is true. So these all are correct statements according to Dalton's atomic theory. Of course, some of them are failed according to modern atomic theory now, but according to Dalton's theory, these all are correct statements. So all will be the right answers. Okay, next one. Charged particles among the following. See here certain fundamental particles are mentioned. Electrons, protons and neutrons. Out of these three fundamental particles, one kind of particles are neutral particles. There are two particles with a charge. Those are electrons and protons which are carrying certain charge on them. Whereas neutrons are having no charge. So they are neutral particles. Based upon this property only, they are named as neutrons. So now, among these electrons and protons, electrons are carrying negative charge, protons are carrying positive charge. Quantitatively, the charge is being equal but opposite in charges. So anyhow here, the charged particles among these electrons, protons and neutrons are electrons and protons. Neutrons are having no charge. Only these two are correct answers. Okay. Next one. Now let us see about comprehension passage type questions. First let us go through the passage given. electrons, protons and neutrons are collectively called subatomic particles. Yes, these three are called, not only these three, the particles present inside the atom are called subatomic particles. But the important three are these three, and hence these are also called as fundamental particles of every atom: electrons, protons and neutrons. Now let us go through the questions based upon this passage. See the first one among those. Which subatomic particles have the same relative mass? So out of these three fundamental or subatomic particles, two particles are having charge, one it is being chargeless. Isn't it? What are those two particles with the charge? They are electrons and protons. They are having relatively same mass but the opposite charges. We know electrons are having 1 unit negative charge relatively, whereas the charge of protons is 1 unit positive. So their relative charge is same, but their charges are in opposite side. Or we can say electrons and protons are having same relative charge. Okay, they're asking here about mass. Mass of electrons is considered as negligible, whereas the mass of proton is considered as 1 unit. So this is not. If you see neutrons and electrons, we consider their charges. Neutrons charge is 0 and electrons charge is -1, means 1 unit negative charge. Whereas mass, if we consider, mass of neutrons is 1 unit and electrons mass is negligible. Isn't it? If we see in case of protons, the charge is +1 and charge of neutrons is 0. Whereas the mass, if we consider, proton's mass is 1 unit and even the mass of neutrons is also considered as 1 unit. Both are having relatively one atomic mass. So these two are having relative mass same. Protons and neutrons is correct answer, not this. Okay, protons and neutrons are having relatively same mass. Of course, to say accurately, the mass of neutrons is slightly greater than that of protons. That's why we say neutrons are the heaviest fundamental particles. But relatively, if they compare, both are having almost same mass. Okay, next. If there are 4 protons in an atom, how many electrons are present? So we know in any neutral atom, the number of protons will be equal to number of electrons. That is why only atoms are existing in the neutral position. The total positive charge because of protons is counterbalanced by the total negative charge of electrons. Hence, atoms are existing neutrally. So, if an atom is containing 4 protons with the positive charge, the same number of electrons will be there with negative charge. Okay, it will contain 4 electrons if it has already 4 protons. But it is in the neutral condition. Okay, next question. Which subatomic particle has the smallest mass? So among the three fundamental particles or subatomic particles, electrons, protons and neutrons, the particle with the smallest mass is electron. Electron's mass is which is equal to 9.11 into 10 to the power of -28 grams. But if it is compared with the mass of any proton or a neutron, it is almost 1837 times smaller than that of these protons and neutrons mass. So we can say that is why generally in calculations the mass of electron will be neglected when compared to the mass of protons and neutrons. So here the subatomic particle with the smallest mass is electron. Okay. Now let us see the matrix matching type questions. Say in the column 1 they have given ask some property of fundamental particles and their quantities are mentioned in the column 2. Try to match these. See the first one, charge of electron. We know relatively charge of electron is 1 unit negative. To say quantitatively, it is equal to 1.602 into 10 to the power of -19 coulombs. This is the charge of electron, which is considered as relatively 1 unit negative charge. Okay, now let us go through the charge of proton. We know the charge of proton is also equal to the charge of electron quantitatively, but it is positive charge, where it is mentioned, say, plus 1.602 into 10 to the power of minus 19 coulombs. Here it is. Okay, this is a charge of proton. Now see the next one, mass of electron. What is the mass of electron? As you told, it is negligible when compared to the mass of protons and neutrons, but quantitatively it is equal to 9.11 into 10 to the power of minus 28 grams. Here it is given, 9.11 into 10 to the power of minus 28 grams. This is the mass of electron. Next, mass of proton. What is the mass of proton? It is actually to say, in average it is taken as 1 AMU. But to say accurately it is 1.007 AMU. The same it is given in grams. It will be equal to 1.67 into 10 to the power of minus 24 grams. So where those two are here, both are given. Mass of proton in grams it is given, and even in terms of AMU also. These two are mass of proton in different units. Okay, observe once the matching. Right? Let us go to next. Statement type questions. See the first statement in this question. Anode rays travel in straight line propagation. Yes, not only anode rays, actually cathode rays and anode rays both were observed as traveling in straight lines in the discharge tube. So this was observed by keeping an object in the path of these anode rays. So when an object is kept in the path of anode rays, they have created shadows exactly back to the object. So when an object is moved, its shadow was also moved. From that experiment, it was proved that anode rays travel in straight line propagation. This is true. Next, anode rays are also called positive rays. Yes, anode rays carry positive charge on them. That's why they're also called as positive rays. We know out of these all kinds of anode rays, the smallest particles are called as protons. Anyhow, all anode rays will be positively charged particles. So they are also called positive rays. What will be the correct answer? Both the statements are true. Here it is. Okay, next one. Statement 1 is given like this. The charge on electron on a proton are equal and opposite. Is it true? Yes. Electron and proton both are having same quantity of charge, but the opposite in charges. Electron is having negative charge, whereas proton is having positive charge, which is quantitatively equal. That is equal to 1.602 into 10 to the power of minus 19 coulombs. But it is negative for electron and positive for proton. Statement 2, what it is going to say? Electrons and protons have the same weight. Is it correct? This is a correct statement, but here it is incorrect statement. Observe once, mass of electron proton are same. No, because mass of electron is very smaller than that of proton. So if we take one electron mass is equal to 1 by 1837 into the mass of proton. Means if you take one proton, to balance the mass of one proton, we need to take around 1837 electrons. So when you compare like this, the mass of electron is said to be very small than that of proton's mass. So it is incorrect statement. Where it is given here, statement 1 is correct, statement 2 is incorrect. Next one. Neutron has no charge. Is it correct? Yes, neutrons are chargeless particles. Based upon that property only, the name neutron was proposed for that. Neutral particles. Second statement, the mass of proton and a neutron are nearly identical. Yes, it is also true. Both are having 1 unit mass, that we say as 1 atomic mass unit. Relatively it is same, but accurately mass of proton is somewhat smaller than the mass of neutron, because mass of proton is taken as 1.007 AMU and that of neutron is 1.008 AMU. Relatively small, but relatively both are considered as 1 AMU. So both are correct statements here. Right, that will be correct answer. Next one. Now let us go through analytical approach questions. See the first among those. The word atom was derived from. Actually, the word atom represents indivisible particle. This was derived from the Greek word atomos or atomio. Atomos, which means indivisible particle. Okay, atom was derived from atomos. Next, atoms have no electric charge because what is the reason for the electrical neutrality of atoms? Are they not containing any charged particles in them? No, they have. But atoms are being electrically neutral. The reason for this is, see what they have given the options. Have equal number of charged and non-charged particles. No, it is not correct. They have neutrons in their nuclei. No, it is not also correct. They have an equal number of electrons and protons. This is correct. Because electrons are having negative charge, protons are having positive charge. If an atom is having equal number of positive and negative charges, they will be counterbalanced by one another and hence finally atoms are existing neutrally. Atoms are being electrically chargeless because the negative charges are being counterbalanced by equal number of positive charges. This is because of the existence of equal number of electrons and protons. This is correct. Okay. Next one. The E by M ratio of an electron for all types of substances. EM ratio nothing but charge to mass ratio for electrons. So this is independent of the gas taken in the discharge tube. It is irrespective of the gas taken in the discharge tube. The E by M ratio will be common for all kinds of cathode rays. So it is said to be constant. The EVM ratio of an electron for all types of substances is constant. Whatever the gas it is taken in discharge tube, the nature of cathode rays produced is being same. So it is being constant. Next, though three fundamental particles are present in almost all the elements, one element does not have. So we have studied that almost all the elements they contain these subatomic particles, three fundamental particles, electrons, protons and neutrons in them. But there is one special element which does not contain one of these three fundamental particles. What is that element? Yes, it is hydrogen. Hydrogen has only two fundamental particles, one each. One electron and one proton only it is having. It has no neutrons. Okay, hydrogen has no neutrons. Except hydrogen, remaining all the elements they contain these three fundamental particles in them in any number. But only hydrogen has two fundamental particles only, electrons and protons, but no neutrons in them. Okay, next one. The discovery of neutron became very late because, yes, they have discovered so long early these electrons and protons, but the discovery of neutrons took so much time. After a long time, they have discovered these neutrons. This is because the electrical neutrality of neutrons. There is no charge effect because of these neutrons presence in the atom. When they try to calculate the masses, then they got controversial concepts there. So because of that, they discovered these neutrons. So the discovery of neutrons became very late because of their chargelessness, which we can say as electrical neutrality, where it is mentioned neutrons are chargeless particles. Because of this, the discovery of those particles became very late. Okay, this is a practice sheet 2, which included level 2 questions from the chapter Introduction to Atom. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates on recorded videos.